Welcome back to the Metabolic Revolution podcast. I'm Dr. Steve Prosciutti, and I am so excited to be here with you today. First off, for all of our followers, I am very sorry for the few-week delay here between episodes. As I'm sure some of you can relate, life has a way of getting very busy sometimes, especially with small kids. But don't worry, we're back and we're not going anywhere. Okay, so where did we leave off? We're not going to miss a beat. We are now in week 5 of our 6-week epigenetics deep dive, and I have to tell you, the response to this series has been incredible. So many of you have reached out saying this changes everything, that for the first time, you understand that it's genetic isn't a life sentence, that you have control. In week 1, we established that genes aren't destiny. Epigenetics is the software running on your DNA hardware. Week 2, we talked about food as code, how nutrients rewrite your genes. Week 3, we expanded the frame to environment as code, how light and temperature rewrite genes. And last week, week 4, we dove into generational patterns and how ancestral experiences shape your current epigenetic profile. Today, we're talking about something that affects every single one of you, something you do every single night, or rather, something you should be doing every single night. We're talking about sleep. And here's what most people don't understand. Sleep isn't just about resting. Sleep isn't just about feeling refreshed tomorrow. Sleep is when your DNA repairs itself. Sleep is when epigenetic reprogramming happens. Sleep is the foundation of all genetic optimization. Without adequate sleep, your DNA accumulates damage. Your epigenetic patterns become dysregulated. Your gene expression goes haywire, and no amount of methyl donors, no amount of polyphenols, no amount of perfect diet can compensate. Because here's the truth. You cannot supplement your way out of poor sleep. This is the Metabolic Revolution podcast from BioSpark Health. I'm Dr. Steve Prosciutti, and today we're talking about sleep, circadian biology, and gene repair. This is the information mainstream medicine completely ignores, because once you understand that sleep deprivation literally damages your genes, once you understand that nighttime is when epigenetic repair happens, their entire just take this pill narrative falls apart. So let's dive in. Let me show you why sleep is the foundation of epigenetic health, and more importantly, how to optimize your nighttime repair protocols. So let's start with the fundamental question. What actually happens while you sleep? And I'm not talking about dreams. I'm talking about what's happening at the cellular level, at the genetic level. Because here's what most people don't understand. Sleep isn't just rest. Sleep is active cellular repair. Sleep is when your DNA fixes itself. Sleep is when epigenetic reprogramming occurs. Let me break this down for you. DNA damage happens constantly. Every single day, your DNA is being damaged. UV radiation, toxins, normal metabolic byproducts, inflammation, stress, all of these things cause damage to your DNA. And your body has repair mechanisms, DNA repair enzymes that fix this damage. But here's the key. Most of these repair mechanisms happen primarily at night, during sleep. One critical repair pathway is something called nucleotide excision repair, NER. This is how your body fixes damage to the DNA structure itself. And research shows that NER activity follows a circadian rhythm. It's highest at night, during sleep, and lowest during the day. There's a specific protein called XPA that's involved in DNA repair. Research shows that XPA levels fluctuate in a 24-hour rhythm, peaking at night. This means your DNA repair capacity is highest at night, if you're asleep. And here's what connects this to epigenetics. When DNA damage accumulates because you're not sleeping enough, your cells activate stress responses. These stress responses include epigenetic changes, changes in DNA methylation, changes in histone modifications. Let me give you a specific example. I had a client, Tom, who came to me thinking he just had bad genes. He was 47, running a startup, sleeping 4 to 5 hours per night for years, high blood pressure, pre-diabetic, inflammatory markers through the roof. His doctor told him it was genetic. His father had heart disease. His grandfather had heart disease. It was inevitable. But here's what his sleep deprivation was actually doing. Every night that he wasn't sleeping, his DNA wasn't repairing. Damage was accumulating, and his cells were activating stress responses, epigenetic changes that turned on inflammatory genes and turned off repair genes. We didn't start with methyl donors. We didn't start with supplements. We started with sleep. Tom started prioritizing sleep, 8 hours minimum, 9 when possible. Same bedtime every night, complete darkness in the bedroom, no screens before bed, and within weeks, his inflammatory markers dropped. His blood pressure improved. His blood sugar normalized. Did we change his genes? No. We changed his gene expression. By allowing his DNA to repair itself properly at night, by reducing the stress on his cells, his epigenetic patterns shifted toward health. Now, let me explain something fascinating about the connection between sleep and DNA repair. There's a concept called transcriptional coupling. When your cells are actively transcribing genes, when they're using DNA to make proteins, this process can actually cause DNA damage. It's part of normal cellular function. But your cells have repair mechanisms that fix this damage. And here's the key. Most of this repair happens during sleep when transcriptional activity is lower. Your cells use the nighttime to catch up on DNA repair, to fix the damage that accumulated during the day. When you don't sleep enough, this repair can't happen. Damage accumulates. And your cells activate emergency stress responses, epigenetic changes that tell your genes, we're under attack, conserve energy, survive. This is why chronic sleep deprivation is associated with increased cancer risk, accelerated aging, neurodegenerative diseases, cardiovascular disease, and metabolic dysfunction. It's not just about feeling tired. It's about DNA damage accumulating. It's about epigenetic patterns shifting toward disease. And here's what most people don't understand. You can't make up for lost sleep on the weekends. You can't supplement your way out of poor sleep. Your DNA needs consistent, adequate sleep for proper repair. Let me share another client story. Jessica was a 36-year-old executive who thought she could hack sleep. She was doing biohacking, tracking her sleep with wearables, taking supplements, doing all the things. But she was still only getting 5 to 6 hours per night. Her body temperature was 96.9 degrees Fahrenheit. Her hair was thinning. Her periods had become irregular. She had brain fog that made it hard to concentrate. Her doctor ran tests and said everything was normal, just stress. Maybe some antidepressants would help. But her temperature told the real story. 96.9 degrees Fahrenheit. That's not stress. That's low energy production. That's a body that's barely maintaining itself. When we looked at her sleep, we saw the problem. She was prioritizing every biohack except sleep duration. Red light therapy, cold plunges, supplements, but only 5 to 6 hours of sleep per night. We changed one thing initially, sleep. 8 to 9 hours every night. Same bedtime, same wake time, complete darkness. Within 4 weeks, her temperature rose to 97.8 degrees Fahrenheit. Her energy improved. Her brain fog lifted. Her periods normalized. Her doctor couldn't believe the transformation. Asked what medication she was taking, Jessica said, "I'm sleeping." The doctor didn't understand, but I do, and now you do too. It wasn't a supplement problem. It wasn't a biohack deficiency. It was a sleep deficiency. Her cells couldn't repair themselves properly at night. Damage was accumulating. Epigenetic patterns were shifting toward disease. Once we restored her sleep, her body could do what it was designed to do, repair itself. Sleep is the foundation. You can't out-supplement poor sleep. You can't biohack your way around it. Your DNA repair mechanisms depend on it. Your epigenetic health depends on it. So we've established that sleep is when DNA repair happens. But here's what most people don't understand. There's a specific hormone that's not just regulating your sleep, it's directly regulating your epigenetic software. I'm talking about melatonin. And I need you to shift your thinking here. Because most people think of melatonin as just a sleep supplement, something you take when you can't sleep. But melatonin is so much more than that. Melatonin is one of the most powerful epigenetic regulators in your body, and understanding how it works changes everything. First, let me explain what melatonin actually is. It's a hormone produced by the pineal gland, that small gland in your brain, and it's produced in response to darkness. When light hits your retina during the day, melatonin production is suppressed. When it gets dark, melatonin production increases. This is your body's signal for sleep. But here's what most people don't understand. Melatonin doesn't just make you sleepy. Melatonin is a direct epigenetic regulator. Let me explain how this works. Melatonin influences DNA methylation. Research shows that melatonin can modulate the activity of DNA methyltransferases, the enzymes that add methyl groups to DNA. It can inhibit excessive methylation in some contexts and promote proper methylation in others. It's an epigenetic modulator. Melatonin influences histone modifications. It can affect how histones are acetylated and methylated, which changes how DNA is packaged and which genes are accessible for expression. Melatonin acts as an antioxidant. And not just any antioxidant. Melatonin is produced within your cells, including the nucleus where DNA is located. This means it can directly protect DNA from oxidative damage. Melatonin activates DNA repair pathways. Research shows that melatonin can stimulate the expression of genes involved in DNA repair. It literally activates the epigenetic programs that fix your DNA. This is why melatonin is so much more than a sleep hormone. It's a master regulator of epigenetic repair. But here's the problem. Most of us are suppressing melatonin production without even realizing it. Remember back in week 3, episode 3, when we talked about light exposure? How artificial light at night suppresses melatonin? This is why that's so damaging. When you expose yourself to blue light at night, from screens, from overhead lights, from any artificial light source, you're suppressing melatonin production. And when melatonin is suppressed, your epigenetic repair mechanisms are compromised. Your DNA can't repair itself properly. Gene expression becomes dysregulated. Let me give you a specific example from the research. There was a study published in the journal Chronobiology International that looked at night shift workers. They found that night shift workers had significantly lower melatonin levels, increased DNA damage markers, altered DNA methylation patterns in genes related to cancer, and increased cancer risk overall. This isn't just about sleep disruption. It's about melatonin suppression. It's about epigenetic dysregulation. It's about DNA damage accumulating because the repair mechanisms aren't being activated. And here's what's concerning. Most of us are living like permanent night shift workers. We have artificial light until we go to bed. We have screens in our faces. We sleep in rooms that aren't completely dark. We're suppressing melatonin production without even realizing it. Now, I know what some of you are thinking. Dr. Steve, can't I just take a melatonin supplement? And here's the thing. Melatonin supplements can be helpful in certain situations, but they're not a substitute for natural melatonin production. Because natural melatonin production follows the proper circadian rhythm, it increases at the right time, decreases at the right time. Supplements don't always replicate this rhythm. Plus, supplements don't address the root cause, which is usually light exposure at night. You can take all the melatonin supplements you want, but if you're staring at screens until bedtime, you're still going to have epigenetic disruption. Let me give you another client example. Mark was a 52-year-old attorney who'd been taking melatonin supplements for years. 5 milligrams, sometimes 10 milligrams, every night. He still couldn't sleep well. He still woke up tired. He still had all the symptoms of sleep deprivation. When we looked at his evening routine, we saw the problem. He was working on his computer until 11 p.m. every night. Then he'd take his melatonin, brush his teeth, and try to sleep. But here's what was happening. All that blue light exposure was suppressing his natural melatonin production. So his pineal gland wasn't producing melatonin properly. Then he was taking a massive supplement dose, which created an unnatural spike but didn't replicate the natural rhythm. We made 2 changes. First, screens off by 8 p.m., complete darkness by 9 p.m. Second, we reduced his melatonin supplement to 0.5 milligrams, a physiological dose that supports rather than replaces natural production. Within 2 weeks, his sleep transformed. He was falling asleep faster, staying asleep, waking up refreshed. His natural melatonin production had recovered because we stopped suppressing it with artificial light. And here's what was happening at the epigenetic level. His DNA repair mechanisms were working properly again. His cells weren't accumulating damage. His gene expression was shifting toward health. Melatonin is a master epigenetic regulator, and you need it to be produced naturally in the proper rhythm, not just supplemented. So what does optimal melatonin production look like? It starts with light exposure. Morning sunlight in your eyes within 30 minutes of waking. This sets your circadian clock and helps establish the proper rhythm. Then, no artificial light for 2 to 3 hours before bed. Blue light blocking glasses if you must be on screens. Dim, warm lighting in your home. Red or orange light is ideal. And your bedroom should be pitch black. Blackout curtains, no night lights. Cover up any LEDs from chargers or electronics. Your sleep environment should be so dark you can't see your hand in front of your face. This allows natural melatonin production to follow its proper rhythm, rising in the evening, peaking in the middle of the night, dropping toward morning. And when melatonin follows this natural rhythm, your epigenetic repair mechanisms work properly. Your DNA repairs itself at night. Gene expression stays optimized. You wake up refreshed, not just because you slept, but because your cells spent the night repairing themselves. This is why sleep is so foundational to epigenetic health. It's not just rest, it's active repair. It's epigenetic reprogramming. And melatonin is the master regulator. So we've established that sleep is when DNA repair happens. We've established that melatonin is a master epigenetic regulator. Now let's talk about what happens when you don't get adequate sleep. What happens to your genes when you're sleep deprived? Because here's the truth that nobody wants to talk about. Sleep deprivation literally damages your epigenetic software. It's not just about feeling tired, it's about gene expression going haywire. Let me break down what the research shows happens when you don't sleep enough. First, DNA methylation patterns become dysregulated. There was a study published in the journal Sleep that looked at what happens to DNA methylation after sleep deprivation. They found that just 1 week of partial sleep deprivation, sleeping 5 to 6 hours per night, caused significant changes in DNA methylation patterns. Genes related to inflammation were turned on. The stress response was turned on. Metabolism was highly dysregulated, and immune function was suppressed. And these weren't random changes. They were consistent with patterns seen in chronic disease. 1 week of sleep deprivation created epigenetic patterns associated with long-term health problems. Second, histone modifications become dysregulated. Sleep deprivation affects how histones are modified, which changes how DNA is packaged and which genes are accessible for expression. Research shows that sleep loss can lead to decreased histone acetylation, which suppresses gene expression. It can alter histone methylation patterns, and it can change the structure of your chromatin. These epigenetic changes affect how your genes are expressed. They're not small temporary effects. They can persist even after you start sleeping better again. Okay? Third, DNA damage accumulates. When you don't sleep enough, your DNA doesn't repair itself properly. Damage accumulates. And this damage triggers stress responses, which cause further epigenetic dysregulation. It's a vicious cycle. One study found that sleep deprivation increased markers of DNA damage by over 30%. And the people in the study weren't severely sleep deprived. They were getting 5 to 6 hours per night. That's what many people consider normal. But here's what 5 to 6 hours per night is doing to your genes. It's disrupting DNA methylation patterns, altering histone modifications, allowing DNA damage to accumulate, activating stress response genes, and suppressing repair genes. This is why chronic sleep deprivation is associated with every chronic disease: heart disease, cancer, diabetes, Alzheimer's, autoimmune conditions. All of them have connections to sleep deprivation because at the root, these are epigenetic diseases. They're diseases of gene expression going wrong, and sleep deprivation directly causes gene expression to go wrong. Let me give you another client story. Lisa was a 41-year-old nurse who worked night shifts for 15 years. She'd rotate between day shifts and night shifts, constantly disrupting her circadian rhythm. She was exhausted all the time. Her weight kept increasing despite eating healthy. Her blood pressure was creeping up. Her doctor told her she was metabolic syndrome and needed medication. But here's what her disrupted sleep was actually doing to her epigenetic software. Every time she worked a night shift, she was suppressing melatonin production with artificial light, disrupting her circadian rhythm, preventing proper DNA repair, and causing epigenetic changes that promoted disease. We couldn't change her work schedule immediately, she needed the income, but we could optimize her sleep as much as possible. On her off days, she kept a consistent schedule. Same bedtime, same wake time. Complete darkness in her bedroom, blackout curtains, eye mask, earplugs. Before night shifts, she'd prepare her bedroom, making it as dark as possible for sleeping after her shift. She wore blue light blocking glasses during her shift to reduce melatonin suppression. She took a low dose of melatonin after her shift to help her sleep. These weren't perfect solutions, but they reduced the epigenetic damage from shift work. Within 2 months, her blood pressure dropped. Her weight started coming down. Her energy improved. Her doctor couldn't explain it, but I can. Her epigenetic patterns were shifting away from disease and toward health, because she was prioritizing sleep despite a difficult work schedule. Now, I want to be clear about something. Sleep deprivation isn't a moral failing. It's not about willpower. Most people who aren't sleeping enough aren't choosing to damage their genes. They're dealing with work schedules that don't respect biology, children who wake up at night, stress that makes it hard to sleep, bedrooms that aren't optimized for sleep, and lights and screens that disrupt circadian rhythms. These are systemic issues, and the solution isn't just sleep more. The solution is to address the root causes. But here's what I want you to understand. Even if you can't get perfect sleep every night, every hour of sleep matters. Every bit of darkness matters. Every reduction in light exposure at night matters. You might not be able to change your work schedule, but you can optimize your sleep environment. You can reduce light exposure at night. You can prioritize sleep in the ways that are available to you. Because here's the truth. Your genes need sleep. Your epigenetic software needs sleep. Your DNA needs the nighttime repair that only happens during adequate sleep. And you cannot supplement your way out of this problem. You cannot biohack your way around poor sleep. You cannot use willpower to overcome the epigenetic damage of sleep deprivation. Sleep is foundational. Everything else, diet, supplements, exercise, stress management, all of it builds on the foundation of adequate sleep. So let's make this practical. How do you optimize your sleep for epigenetic repair? What specifically should you do to support DNA repair, melatonin production, and proper gene expression during sleep? I'm going to give you my complete nighttime repair protocol. These aren't sleep hygiene tips. These are epigenetic interventions. They're directly programming your genes for repair and optimization. First thing in your day, morning light. It sets your entire circadian rhythm. Remember back to episode 3 when we talked about light exposure? Morning sunlight is the foundation of proper circadian rhythm. It sets your internal clock. It establishes the timing for melatonin production that evening. Within 30 minutes of waking, get outside. No sunglasses. Let the natural light enter your eyes. Not staring at the sun, don't do that, but just being outside, letting the light hit your retina. This activates special cells in your retina, specialized cells that respond to blue light. They send a signal to your suprachiasmatic nucleus, your master circadian clock. This starts a cascade that sets your cortisol rhythm for the day and establishes when melatonin will rise that evening. It also activates clock genes that regulate gene expression and triggers epigenetic changes that support proper sleep-wake cycling. Morning sunlight literally programs your genes for proper sleep that night. Okay, second, evening light avoidance. protect melatonin production. 2 to 3 hours before bed, no screens. No phone, no computer, no TV. If you must use a screen, put on blue light blocking glasses. Use dim, warm lighting in your home. Red or orange light is ideal. This prevents melatonin suppression. It allows your natural melatonin production to begin on schedule. And here's what most people don't understand. Even DIM blue light can suppress melatonin. A tablet screen on dim brightness is still enough to disrupt your circadian rhythm. So it's not enough to just dim your screens. You need to block blue light or eliminate screens entirely. Red light therapy in the evening? That's different. Red light doesn't suppress melatonin. In fact, red light exposure can support mitochondrial function without disrupting circadian rhythm. So red light therapy is fine in the evening. Blue light from screens is not. On to number 3, complete darkness, non-negotiable. Your bedroom should be pitch black. Blackout curtains, no night lights. Cover up any LEDs from chargers or electronics. Your sleep environment should be so dark you can't see your hand in front of your face. If this isn't possible, get a good sleep mask, one that blocks all light. This darkness allows melatonin levels to peak properly. It supports the epigenetic repair mechanisms that happen during sleep. It's non-negotiable for optimal health. Okay, number 4 is temperature, warm for sleep. I know there's a lot of advice about sleeping in a cold room, but here's the bioenergetic perspective. Your body temperature naturally drops during sleep. You don't need to force it down further with a cold bedroom. Keep your bedroom warm, around 70 to 72 degrees. Your body will regulate its temperature drop naturally. A warm room supports deeper, more restorative sleep without the stress of cold exposure. Comfort isn't laziness. Comfort is the foundation of optimal metabolic function, and your sleep should be comfortable, not a challenge. 5th, timing. Consistency matters. Same bedtime, same wake time, every day, even weekends. Your circadian rhythm thrives on consistency. When you vary your sleep schedule, you're disrupting the timing of epigenetic repair processes. You're confusing your genes. If you can only do one thing from this protocol, make it consistency. Same bedtime every night. Your epigenetic software will thank you. 6th, pre-sleep nutrition. Don't go to bed hungry. Remember back to episode 2 when we talked about methyl donors needing energy? Methylation requires ATP, and if you haven't eaten in hours, your energy production is compromised. Eat dinner 3 to 4 hours before bed, but don't go to bed hungry. If you need a small snack before bed, have something with carbs and protein, a little fruit, some yogurt, warm milk. This provides the energy your cells need for nighttime repair processes. It supports the methylation that happens during sleep. 7th, movement during the day, not right before bed. Regular exercise supports sleep quality. It helps regulate circadian rhythms. It supports epigenetic health. But avoid intense exercise within 2 to 3 hours of bedtime. Exercise raises cortisol and body temperature, which can interfere with sleep onset. Gentle movement is fine, stretching, yoga, a slow walk, but save the intense stuff for earlier in the day. 8th, wind down ritual. Signal your body. Create a pre-sleep ritual that signals your body it's time to sleep. This could be reading, physical books, not screens, gentle stretching, meditation or breathing exercises, or even a warm bath or some herbal tea. The same ritual every night creates a Pavlovian response. Your body learns that this ritual means sleep is coming. It starts the epigenetic cascade toward rest and repair. 9th, manage stress during the day. Stress hormones like cortisol should be highest in the morning and drop throughout the day. If you're chronically stressed, cortisol stays elevated. This interferes with sleep and suppresses nighttime repair. Address stress during the day, not at night. Process emotions, set boundaries, take breaks, support your nervous system. This keeps cortisol on its proper rhythm and supports nighttime repair. Now let me put this all together into a complete evening protocol. 6 p.m., finish dinner. 3 to 4 hours before sleep allows digestion to complete before bed. 7 p.m., no more screens. Turn off the TV. Put away the phone. If you must be on a screen, wear blue light blocking glasses. 7:30 p.m., red light therapy or warm bath. Supports mitochondrial function without disrupting circadian rhythm. 8 p.m., wind down ritual. Read, stretch, meditate. Something calm and consistent. 9 p.m., bedroom preparation. Make sure your bedroom is completely dark. Cool the temperature if needed, but not too cold. 70 to 72 degrees is ideal. 9:30 p.m., bedtime. Consistency matters. Same time every night. 5:30 a.m., wake up. Same time every day. Within 30 minutes, get outside for morning sunlight. This protocol isn't just about better sleep. It's about epigenetic optimization. It's about supporting DNA repair. It's about proper gene expression. Let me share one more client story. Rachel was a 29-year-old new mother who hadn't slept more than 3 to 4 hours at a time in months. Her baby was waking up every 2 to 3 hours. She was exhausted. Her temperature was 96.4 degrees Fahrenheit. She was losing hair. Her mood was unstable. Obviously, she couldn't control her baby's sleep schedule, but we could optimize her sleep as much as possible. We focused on complete darkness in the bedroom, even during daytime naps, going back to sleep immediately after feeding the baby, eating nutrient-dense foods to support energy production, getting morning sunlight whenever possible, even with the baby, keeping bedtime consistent when she could. She couldn't get perfect sleep, but she optimized what she could control, and within a few weeks, her temperature rose to 97.6 degrees Fahrenheit. Her energy improved, her mood stabilized, her body was able to do more repair during the broken sleep she was getting, because we optimized the sleep environment, because we supported her epigenetic software as much as possible given the constraints. This is what I want you to understand. Perfect sleep isn't always possible, but optimized sleep is almost always possible. Every bit of darkness matters. Every bit of consistency matters. Every bit of sleep optimization matters. Your genes need sleep. Your epigenetic software needs sleep. Your DNA needs nighttime repair. And you have more control over these processes than you think. So let's recap what we covered today. It's week 5, and we've been talking about sleep, the foundation of epigenetic health. Your DNA repairs itself while you sleep. DNA repair mechanisms, like nucleotide excision repair, are most active at night. Sleep deprivation allows DNA damage to accumulate and causes epigenetic dysregulation. Melatonin is a master epigenetic regulator. It influences DNA methylation, it modulates histone modifications, it activates DNA repair pathways, it acts as an antioxidant directly in the nucleus where DNA is located, and natural melatonin production is suppressed by artificial light at night. Sleep deprivation literally damages your epigenetic software. Just 1 week of partial sleep deprivation causes significant changes in DNA methylation patterns. These changes are consistent with patterns seen in chronic disease. And you cannot supplement your way out of poor sleep. You cannot biohack your way around sleep deprivation. Sleep is foundational. Everything else builds on this foundation. If you're not sleeping enough, start there. Before methyl donors, before polyphenols, before any other intervention, optimize your sleep first. Here's what I want you to do this week. Track your sleep. How many hours are you actually getting? Be honest. Most people overestimate. Create darkness, blackout curtains, eye mask, cover LEDs. Make your bedroom pitch black. Evening light avoidance. No screens 2 to 3 hours before bed. Blue light blocking glasses if you must. Dim, warm lighting. Morning light. Within 30 minutes of waking, get outside. Let sunlight in your eyes. Sets your entire circadian rhythm. Consistency. Same bedtime, same wake time, every day, even weekends. These 5 changes alone will transform your epigenetic health. Within 2 weeks, you'll notice the difference. More energy, better mood, improved temperature, clearer skin. Because your genes need sleep. Your epigenetic software needs nighttime repair. Your DNA needs the darkness that allows proper melatonin production. Next week, week 6, is our final week of this epigenetics deep dive, and we're going to bring it all together. We're going to talk about the complete epigenetic reset protocol, how to optimize all the inputs that affect your gene expression: food, environment, stress, sleep, and more. You're not going to want to miss it. If you're struggling with sleep, if you know you're not getting adequate rest, if you want to optimize your epigenetic repair protocols, we can help. We offer a free metabolic assessment at biosparkhealth.com. We'll evaluate your sleep patterns, your lifestyle factors, your symptoms, and create a personalized protocol to optimize your epigenetic health. Because here's the truth that mainstream medicine will never tell you. Sleep is not optional. Sleep is not a luxury. Sleep is the foundation of epigenetic health. Your doctor might tell you to take a pill for your symptoms. They might tell you to eat better or exercise more. But they're not going to tell you that your symptoms are caused by epigenetic damage from sleep deprivation. Because once you understand that sleep is when your DNA repairs itself, their entire narrative falls apart. You realize that the solution isn't another pill, it's better sleep. You have control. Your epigenetic software responds to sleep. Your genes express health when you sleep adequately. This is the revolution. This is the science that changes everything. You are not a victim of your genes. You are the author of your genetic expression. And sleep is your most powerful tool for writing better code. Every night of adequate sleep is upgrading your epigenetic software. Every night of darkness is allowing DNA repair. Every night of proper melatonin production is programming your genes for health. So, what code will you write on top of your genes tonight? Okay, that's it for this week's episode. Again, my sincere apologies for the few-week delay here between episodes. Again, we're back on track, and the last installment of our exciting epigenetics mini-series will be released next week. Remember, you came to the right place. Let's talk.